Welcome back to the channel in Hypnotic. I am Gagan. We have previously seen binary search and linear search and have a fair idea how search algorithms work. Now let's go into sorting algorithm. First, let's see selection sort. Selection sort is one of the brute force algorithm which we can apply. Brute force algorithms are those algorithms which we apply if we find no other possibilities to do. So, in selection sort, what exactly we do? So there are two main steps which we have to do. First is find the smallest element in the array. First we have to find the smallest element which is present in the array, and the second step is to swap it with the first element of the array. So the entire algorithm works on these two principles itself. Now let us understand how selection sort works with an algorithm. Now let's consider the following array having elements 64, 25, 12, 22 and 11. Now first we'll do the step 1. Step 1 states that find the smallest element in an array. Now we can find the smallest element using linear search or any other search. So now since this is a brute force method, we will try finding it using the linear search. On scanning the array, we get to know that the smallest element is 11 here. So step 1 is done. Now step 2 is to swap the element with the first element of the array. Now we have to swap this element with this. So the resultant array would be 11, 25, 12, 22 and then 64. Now this would be the resultant array after these two steps. Now followed by this we have a third step. In the third step we have to repeat the steps 1 and 2 with array first element to the last element. So now what it states that after the first iteration all the elements before the first element is sorted and all the elements after this first element has to be repeated selection sort again. Now let's continue this example. So the example which we had was 11, 25, 12, 22 and 64. Now this was the array which we got after the step 1. Now we know that this part of the array is sorted. Now we have to take this part of the array and do the selection sort again. So here we have to find the smallest element. Here the smallest element is this. Then we have to swap the smallest element with the first element of the array, this. On again further swapping we get 11, 12, 25, 22 and 64. Now this would be the array after the second iteration, meaning these two positions are now sorted. Now again we have to continue the selection sort for the rest of the array. Now again finding the smallest element and then swapping it with the first element. We get 11, 12, 22, 25 and 64. Now this would be the array after the first, stating that these elements are sorted, this we have to do again. So since this is the smallest element, this would be swapped again to this position. So our final array would be 11, 12, 22, 25 and 64. So this would be our final array. So now that we got to know how exactly selection sort works, its math behind it, now let's see the algorithm. So the algorithm here is for I ranging from 0 to n minus 2. That is, from the first element to the last but one element of the array, we make an element min is equals to I, stating that the first element would be the first element of the subset would be the minimum element. Then again we have to write the for loop for j is equals to I plus 1 to n minus 1. So this j loop is running inside the subset of the array. So example, here this would be the third iteration. In the third iteration, we know first two would be arranged in proper order. So these three wouldn't have been. So I would be here 3 because this is the third, and then j would be running on this part of the loop. So after running on the loop, then we have to check if a of j is lesser than min. If that is lesser than min, then I have to make min is equals to a of j. After finding the smallest element, then I have to swap a of min and a of j. So this is our algorithm for selection sort. Now that we know the algorithm, let's try to find the time and space complexity. Here we know in the algorithm there are two loops which are running. So the statement which is running all the time is the comparison statement which is inside the second loop. So now let's see. So the basic operation would be the if statement inside the second loop. So we must know how many times the basic loop is run. So that we can get to know with the conditions given in the two for loops. So that is nothing but sigma I is running from 0 to n minus 2, and then followed by another sigma where j is running from I plus 1 to n minus 1. Since I have just written the conditions from where to where the loops are running. So these are the loops, and the if statement is running only once inside the for loop. We know the formula sigma I is running from lower bound to upper bound. Upper bound 1 is equals to upper bound minus lower bound plus 1. Now on applying this formula here, we can get to know that it is sigma I is running from 0 to n minus 2 and followed by upper bound n minus 1 subtracted by the lower bound I plus 1 and then plus 1. So on solving this, we get sigma I is equals to 0 to n minus 2 n minus 1 plus I. So we know that sigma can be split between 2 if there is addition or subtraction operation. So this can be rewritten as sigma I is equals to 0 to n minus 2 n minus 1 plus sigma I is equals to 0 to n minus 2 I. So this is nothing but the previous expression which we got. So we can also write removing n minus 1 outside the sigma, writing the previous formula n minus 2 that is upper bound minus the lower bound plus 1. For the second part of this here equation, we know sigma I is equals to 0 to n I is equals to n into n plus 1 by 2. This is nothing but the sum of n numbers in series. So here this, since it is n minus 2, it would be n minus 2 into n minus 1 divided by 2. Now on further simplifying this, we get n minus 1 into n minus 1 plus n minus 2 into n minus 1 by 2. This can be written as n minus 2 into, by taking n minus 1 common, n minus 1 into, on solving we get n by 2. So on solving C of n, we get to know that C of n belongs to theta of n square. This on simplifying we get n square minus n by 2. So we have to take the higher coefficient. So C of n would be theta of n square. So what we get to know from this is, as the input size of the array increases, the time complexity would be increased drastically. So this was all for selection set. If you have liked it, please do like, share and subscribe. Thank you.